A substance's density is its mass per unit volume. Traditionally, the density values of solids are expressed in grams per cubic centimeter, and the density values of liquids are measured in grams per milliliter. You should know that 1 milliliter is the same volume as 1 cubic centimeter. These two units are interchangeable. So, 1 gram per milliliter and 1 gram per cubic centimeter are the same density. One way to think about this property is in terms of the space between a substance's atoms. The closer a substance's particles are to each other, the greater its density. Let's look at some substances with different densities. These two cubes are made of two different metals. The larger cube is made of aluminum, whereas the smaller cube is made of copper. Judging by the size of each cube, you might think that the larger cube has more mass. Surprisingly, it doesn't. The aluminum cube weighs the same as the copper cube. Still not convinced? The aluminum cube weighs 21.0 grams, and the copper cube weighs 21.0 grams as well. So how can two objects with such different sizes have the same mass? The answer has to do with each substance's density. The two cubes have the same mass, meaning that they have the same amount of matter. However, the matter in aluminum is more spread apart, making it less dense than copper. The same amount of matter in copper is tightly packed in a smaller volume, making it more dense than aluminum. Let's look at another example. Here are two bars, one made of aluminum and one made of copper. Clearly, they have the same volume. By placing the objects on the balance, we see that the copper bar has more mass than the aluminum bar. So how can two objects of the same volume have different masses? Again, the answer has to do with each substance's density. Notice how the matter in the aluminum bar takes up the same amount of space as the copper bar. But because the matter in aluminum is more spread apart, it is less dense. Conversely, the copper bar is more dense because it has more matter in the same amount of space. We know the copper bar and the copper cube are more dense than the aluminum bar and the aluminum cube. But which is more dense, the copper bar or the copper cube? The answer is that they have the same density. Let's look at density mathematically to understand why this is so. The copper bar's mass is 71.5 grams, and its volume is 8 cubic centimeters. The copper cube's mass is 21.0 grams, and its volume is 2.35 cubic centimeters. If we arrange these measurements as ratios of masses over volumes, we'll see that even though the masses and volumes are different, the ratio of the mass to the volume in both the bar and the cube are the same. This ratio is copper's density. The density of copper is the same, regardless of the size of the sample.